everybody, welcome back to my channel. Today let's continue with an example from transportation section. Calculate and verify the stopping distance on a rural highway with a downgrade of 4% and a design speed of 70 miles per hour. So stopping side distance, this is the terminology you're going to find in the FE handbook. And we're going to go to FE handbook under the transportation stopping side distance. I guess you just do a search stopping side distance and it's going to lead you here. And this is the formula for stopping side distance. It's 1.47 design speed multiplied by driver reaction time plus design speed squared over 30 multiplied by A, which is deceleration, divided by 32.2 plus minus G, which is percent grade divided by 100. And uphill is positive, downhill is negative. And actually, since we are here, plus minus the percent grade divided by 100G, if in the problem they are not specifying if you are uphill or downhill, the most conservative is to consider negative downhill. And this is because I'm going to try and draw this. Imagine if you are going downhill, right? And you're trying to stop, the stopping side distance is going to be greater than if you're trying to stop going uphill, right? Because there is I guess gravity, it has something to do with it. You're going downhill, it's gonna take you, the distance is gonna be a little bit greater than if you're trying to stop going uphill. So in the problem, if you're not given the sign downhill or uphill, consider it negative. That's the most conservative. And another thing that I wanted to talk to you about is this formula, stopping side distance. If we look at every single component, so let's say design speed is in miles per hour, and then we look at T, which is driver reaction time, is in seconds. So miles per hour, and then you have seconds, and you might think, oh, I'll have to do some transformations. But you actually don't have to, because this is where 147 comes in place. 147 takes care of these transformations. So all units are okay the way they are, seconds and miles per hour. Another important thing is you have two components when calculating stopping side distance. You have component number 1 and number 2. So this component, number 1, this is actually, so let me say, this is 1 and then this is 2. So number 1 is also called reaction distance. And number 2 is called braking distance. And why is this important? It's important to know that sometimes you might be asked to calculate the reaction distance, right? So if you are asked to calculate that, you're only going to use this first part of the formula, 147 multiplied by V multiplied by T. And you also might be asked to only calculate the braking distance, in which case you're going to use this second part of the formula to calculate the braking distance. So in order to calculate the stopping side distance, you have to add these two together. Wonderful. So we've covered that. Now there is another last thing that I have to add here, which is there are some default values for driver's reaction time. In case in the problem on the exam, they are not giving this value to you, I want you to know that the default value for driver reaction time is 2.5 seconds. And the default value for deceleration is 11.2. Also, in case they are not giving it to you in the problem. If they give you the value in the problem, of course, use that value. In case they don't give it to you, use 11.2 feet per second squared. And There you go. I believe we have covered everything that we need to solve this problem. So let's go ahead and write the formula down and find the stopping side distance. So stopping side distance equals 147 multiplied by design speed multiplied by reaction time plus, then we have v squared. Here we have 30 multiplied by deceleration divided by 32.2, and then we have plus minus g equals. Now I will go ahead and write each component down. We have v equals to 70 miles per hour, and we have downgrade, which means that our g equals to minus 4%, which is equal to minus 0.04. And it's minus 0.04 because we are being told in the FE handbook it's percent grade divided by 100. And it's positive for uphill, it's negative for downhill. Now you're noticing in this problem, we are not given the reaction time. So I'm going to use the default value, which is 2.5 seconds. And then A, also it's not given in the problem, so we're going to use the default value of 11.2 feet per second squared. Wonderful. I think everything else we have, so we can proceed in calculating the stopping side distance. I'm going to continue here. So I'm going to have 1.47 multiplied by 70 and multiplied by 2.5. And then I'm going to have plus, I have 70 squared divided by 30, then 11.2 divided by 32.2, and then this is minus 0.04. And now all we have to do is solve this equation, and here's a chance for you to practice using your calculator. So let's do this. 11.2, 32.2 divided 0.04 minus 30 multiplied, and then we have 70 squared, then we'll divide. All right, and next we have 1.47, 70 multiplied, 2.5 multiplied, and then we will add this up. So I am getting a value of 787.85, and these are feet. So it seems the closest is D, 788.3 feet. That's all I had for today in regards to stopping side distance. I hope you found it helpful. If you did, as always, I'm going to remind you, don't forget to subscribe and give it a like, because this helps put this video in front of more people just like you. If you have any questions about this video, please leave your questions in the comment section below. Keep up the good work on practicing the FE problems, and I will see you next week.